Welcome back, everyone, for another deep dive. You know we love getting your questions, and one of the most fascinating ones comes straight from Alessio Guarino's book, 100 Everyday Science Questions Answered.
Oh, a classic.
It really is, and it's all about something we see almost every day,
hmm
a candle flame. Have you ever noticed how it's always dancing upwards? It's almost as if it's defying gravity.
Yeah, you'd think it would just kind of stay put, right? But there's this invisible force pulling it up.
Totally. So what's the secret behind this upward dance? Is there some sort of mini rocket inside the flame?
Well, not quite. The truth is the flame isn't actually knowing which way is up. It's all about the physics of heat and air.
Okay, so how does that play into it?
Right, so think about it. When the candle burns, it generates heat, right? That heat warms up the air right around the flame. And guess what? Warm air is way less dense than cooler air.
Right, so it's lighter.
Exactly. Like think of air at room temperature. It's about 1.2 kilograms per cubic meter.
Okay.
But when a flame heats it up, it can become like 20% less dense.
Wow, that's a big difference. So what happens to this lighter air? Does it just hang around?
Nope, it wants to rise. It's like a helium balloon surrounded by denser air. That's buoyancy in action.
Ah, buoyancy, right. Like how things float in water.
Precisely.
Mhm.
And there's this principle called Archimedes' principle, which basically says that an object in a fluid like air feels an upward push that's equal to the weight of the fluid it shoves out of the way.
Okay, that makes sense. So the lighter, warmer air gets pushed up by the denser, cooler air around it.
Exactly. So it's not that the flame itself is rising, but the heated air is carrying it upwards,
Yeah.
and that's where convection comes into play.
Convect, right. So is that like how heat travels?
You got it. Convection is all about how heat transfers through the movement of fluids like air or water. So as that warm air rises, thanks to buoyancy, it's carrying the heat and the flame, which is basically just the burning gases giving off light along with it. Think of it like boiling water in a pot.
Oh yeah, the hot water always rises to the top. So the shape of the flame is just a visual of this rising hot air current.
Precisely. The flame's just along for the ride, following the path created by the heated gases from its own burning. It's all tied to this buoyant force, which has a fancy equation. FB equals rho times V times G. Rho is the density of the air, V is the volume of the heated air, and G is gravity. But the key is, as long as there's a difference in density, that upward push is going to be there.
So let me see if I've got this straight.
Mm.
The burning wax heats the air, making it less dense. Then this lighter air gets an upward push from the cooler, denser air around it, this buoyancy. And as this warm air travels upwards, it carries the flame with it through convection. So the flame points up because the hot air is going up. Did they get it?
Nailed it. And here's a mind-blowing thought. Imagine a candle flame in space where there's no gravity.
Ooh, what would happen?
Well, without that constant upward push from buoyancy, the heat and gases would spread out in every direction. You'd probably end up with a spherical flame.
A spherical flame. That's incredible. So the next time we see a candle flame, we're not just seeing fire. We're seeing this awesome interplay of heat density and these invisible forces of buoyancy and convection.
It's like a hidden dance happening right before our eyes.
It really makes you wonder what other everyday things around us have these surprisingly complex scientific explanations behind them. Thanks so much for this illuminating deep dive.
My pleasure. Always happy to explore the wonders of science.
And to our listeners, keep those questions coming. Until next time.